Welcome to ilectureonline, and by special request from one of the viewers, I'm going to do a small series on what we call rigid body rotations. And we'll start out with some basic principles of rigid body rotation. So first of all, the best thing to think about it would be like having a wheel, like a tire of a car. So when a car is driving, the car is moving forward, the wheels are turning. What is each little piece of the tire doing as the car is driving and the tire is rotating? Well, for one thing, there are two different kinds of motions that are happening at the same time. The car is moving forward, so we call that translational motion. That means every piece on the tire, every piece on the wheel, at the center, at the edges, everywhere, is moving to the right at a certain velocity. Whatever the velocity of the car is in the x direction, that will be the motion of a particle on that rigid body moving to the right. At the same time, the tire is also rotating. So we go back to rotational motion, and that means that every part of the tire is also moving in a direction tangential to the edge of the tire. So we have that relationship between the angular velocity and the velocity along the edge, tangential velocity, and this is of course a relationship right there, that omega is equal to v sub x divided by r, or if you want to then rewrite this equation, that v in the x direction is equal to r times omega. So let's call this v sub x translational, and instead of calling it v sub x here, I'm going to call this v tangential, so that way we don't get confused. So we'll call this v tangential. That's probably a better way to talk about it. And so what we need to do then is we need to combine those two velocities to figure out what the velocity is on each particle in the tire as the tire is rotating and moving forward at the same time. So these are definitely vector quantities. This velocity is only in the x direction, but this velocity can be any direction along the rotation of the tire. So over here the velocity is to the left, over there the velocity is to the right, here it's down, and there it's up. So when we combine the velocity, it's like a vector addition. At the bottom, notice that we have a velocity translational to the right, and then we have velocity tangential to the left. They have to be equal in magnitude. That makes sense. And so they will cancel each other out. And so for a moment there, the bottom of the tire relative to the road is not moving at all. So it's stationary. On the other hand, at the top of the tire, we have the translational motion to the right, and we have the tangential motion to the right. They're additive, and so you can see here that the top of the tire is moving to the right at twice the velocity of the motion of the car. For example, if the car is moving at 60 miles per hour, then the very bottom of the tire is at a moment stationary, motionless completely, and at the very top of the tire is moving at twice its speed of 120 miles per hour. So you can imagine the tremendous acceleration of a particle on a tire. When it's at the bottom hitting the road, it's not moving at all. When it's at the top, it's moving 120 miles per hour back and forth like that. Tremendous accelerations, which is part of the reason why there is a lot of heating effect taking place by the rotation of the tire like that. Notice that the very center of the tire is not affected by the rotational motion, so therefore the center of the tire is moving always at the speed of the car at, let's say, 60 miles per hour. But then on the other side, like for example on this side right here, that side right there, we simply have to do a vector addition. You can see that the velocity of that particle in the tire at this moment is moving in this direction, and the velocity of this portion of the tire at this moment is moving in that direction. So those are the basic principles. Just remember that it's always a combination of the translational motion vector and the rotational motion vector tangential to the edge of the tire, and that is what defines then the motion of the tire as the tire rolls around. Now it doesn't have to be a tire, it could simply be a cylinder rotating or a sphere rotating or something like that. It always has that same principle. So keep that in mind as we go through the next so many videos.